We're talking about how to actually find the proper equation for a parabola. So y equals ax squared plus bx plus c, if you know the zeros. And when they say the zeros, they mean the points where it goes through the x-axis. So I'm going to draw an example here. Well, not an example. I'm not going to give us any definite numbers. This is y and this is x. And we've got an equation. I'm just going to assume it's going to be a smiley face. These are the zeros. And in this generic formula they've given us, they've called them alpha and beta. That's because they want to be fancy. We might be told what they are and use that information to find the rest of the equation. The good thing about all quadratics is we start off with them in this general form, y equals ax squared plus bx plus c. But because we can factorize them, and you can use the quadratic formula if you can't factorize them, then we can actually write them in the form ax take alpha, where alpha is our first zero. Just like back up here when we factorized to figure out the x-intercepts, just like here. These are our zeros, so our 0 was positive 4 on 3, and our other 0 was negative 2. We're putting it back into brackets, but we don't actually know what's inside these brackets, so I'm calling it alpha and beta. That's a really complicated way to do what I'm about to show you what to do. So this kind of makes more sense if you get an example, and I'm actually going to draw a picture of this. So if the zeros are minus 2 and 4, then it's going to look something vaguely like this. Now before I do the question, I don't actually know its turning point. I will once I've done the question. I don't actually know its turning point. All I know is that it goes through the x-axis at minus 2 and positive 4. So I don't even know if it goes up or if it goes down. It could look like this, or it could look like this. You know, it could be anything like this. So when they say write down the family of quadratics with those zeros, well, all I know really is, if I do example A, all I know really is that in the brackets, I'm going to have a y equals, in the brackets I'm going to have x plus 2, x take 4, but I really don't know how steep it is. I don't know whether it's going to go up or down, so I'm going to just chuck an A out the front, because whatever's out the front is going to tell me whether it's, well, if that number's positive, then that's going to tell me that it's smiley face, and if it's negative, it's going to tell me it's a sad face, and it's going to tell me how steep it is. So if I then do example B, if I do then question B, they've now given me more information. They've said that the y-intercept is 16. What information is that though? So from my generic answer in A, I had y equals A outside of x plus 2, x take 4. They've said the y-intercept is, did they say positive 16 or negative? Positive 16. So at the y-intercept, x equals 0. That's the important thing with y-intercepts. So I know that positive 16 equals whatever this number out the front is, times 0 plus 2, times 0 take 4. So 16 is the same as A times positive 2 times negative 4. So 16 equals A times, and that's going to come out as negative 8. So 16 divided by negative 8, negative 2 equals A, which means my formula is y equals, now I know the number out the front, x plus 2, x take 4. Now we've done enough maths that we know how to sketch this now. I'm not going to bother. Why bother? They haven't asked us to. Have they? No, just write down the equation. Okay, question II says it passes through the point So I've got my y equals a outside of x plus 2, x take 4, and it goes through 5, 1. So I know that the x value, x coordinate, is 5. This is just at one point along this graph, by the way. I'm just using this as a handy point because, well, they've given it to me, why not? And the y coordinate comes out as 1. So I'm substituting those in, and I'm going to find out this value for a, and then I'm going to be able to like write down just like I did on this one on the left. So I've got 1 equals a outside of 5 plus 2, 5 take 4. 1 equals a outside of plus 2, 5 plus 2 is 7, 5 take 4 is 1, so 1 equals a times 7. So I've got 1 on 7 equals a. So if I want to rewrite my formula, y equals 1/7 x plus 2 x take 4 is now the proper formula for that thing. I could type that into decimals or I could sketch it by hand. Not going to bother. They're fairly simple. Sometimes with those questions, they'll actually give you a graph and then ask you to find the equation given that. So let's do it. Yx. Oh, I should like make it another example. Find the equation. Why did I write that? Find the equation. And they're going to tell me maybe it goes through -3, +2, and its y-intercept is 6. So maybe it looks like that. And I've got to find the equation. So I'm going to start off with my y equals a, x take alpha, or x plus alpha, really doesn't matter, x plus beta. I don't know a yet, but I do know alpha and I do know beta because they're the zeros. Don't forget I have to change the signs when I put them back in. So sub in zeros for alpha and beta. So now I have y equals a outside of x plus 3, x take 2. You always change the signs when you're putting them back into brackets. Okay, I do know another point. I know that this is 6. So now I'm going to substitute that in. So the y-intercept is 6 and x equals 0 at that point because, you know, it's a y-intercept, x is 0. So 6 equals a outside of 0 plus 3, 0 take 2. 6 equals a, 0 plus 3 is 3, 0 take 2 is -2. So 6 equals a, and it comes out as -6. That was weird. So I'm going to divide both by -6. I'm going to get -1 equals a. That gives me enough information. I now know that y is -1 outside of x plus 3, x take 2. And do I really need to write that 1? No. So y equals -x plus 3, x take 2. That's it. Sorry that's so messy. I need to work on my handwriting for these. Thank you for watching and enjoy these. That's the kind of last new information that you need. These are kind of really simple, right? They are really simple, relatively. Thanks. Bye.